Hi, today I'm going to talk about our differential equation group assignment. Our topic of discussion today is compound interest, and we are from group 9. Our team consists of 7 members, which is me, Won Yanjun, Teo Jiaren, Yu Gongyuan, Eugene, Li Zewei, and Benjamin Lin Shihen. Differential equation in regular investment plan. When investing, we regularly face with the issue of finding the compound interest. Differential equation can be used as a tool to calculate the compound interest and the ROI, which stands for return on investment. So what is differential equation? Differential equation is a rule that defines how a quantity changes over time or space. Differential equation is a mathematical tool that can be used to describe the relationship between a function and its derivatives. So there are a few types of first order ordinary differential equation, which is separable, homogeneous, exact, linear, and Bernoulli equation. In this presentation, we are going to use separable differential equation.
Okay, next I will talk about the regular investment plan. So what is regular investment plan? A regular investment plan is an investment strategy in which I invest a set of amount of money at fixed interval. It can be either monthly or quarterly. So this method is usually allowed to earn money slowly through the disciplined, consistent investing. So this can benefit in a long-term financial goals. It also will provide a high affordability to individuals and it require a smaller initial investment. Means that there is not large sum of money is needed to invest. So in a fixed amount of investment lead to more rational investment behavior which can avoid risk of bankrupt. Next, I will talk about what the compound interest. What is compound interest? A compound interest is the interest calculated on both of the initial principal, which is the original amount of money, and all of the previously accumulated interest. This means that the individual can earn the interest is not just on the initial investment, but also on the interest that is accumulated over the time. So this scenario is called the interest on interest. Simply say, the amount of interest earned is based on the initial investment plus the interest and not fully based on the initial investment only.
Now we come to the formula in the compound interest. This is the formula of the compound interest. S bracket t is the amount of money at time t. Our delta t is the interest accrued. Kt is the total contribution or withdrawal over the time t. We wish to make the to turn to the equation below. And now Eugene will demonstrate us how it could be done.
So we will now modify this equation until we may simply apply the equation to get the final result by setting the initial value. We first take delta t out and move st and delta t to left-hand side. Then, by taking delta t approach to 0, we can obtain the equation for continuous compounding of interest and continuous deposits. You may now know what type of first-order ordinary differential equation it is. It is a separable equation with dependent variable of s, independent variable of t, and two constants r and k. Let's solve this equation with what we learned. Now, let the s when time just begin be s0, and the s when time's up to be s. And here simply start at 0 and end at time t. We may start integrate it now. Then we can know it will become a ln. For the right hand side, it is very simple. 1 will become t. And so this will become t minus 0 equal to t. Let's do the left hand side. We expand it out first. So according to the properties of loan, let it become, and we continue rearrange the equation until only s exists at left-hand side. Now, you can know your compounding results S by applying your initial invested capital S naught, annual interest rate R, the overall length of time the interest is applied T, and your annual deposit amount K by this formula.
Differential equation problem statement. Jasper, who is a first-year university student, he decided to start investing earlier for his retirement. He has an initial principal for 2,000 ringgit Malaysia. Jasper plans to deposit an additional 1,000 ringgit Malaysia at the beginning of each subsequent years into a retirement fund that offers a 4% annual interest rate, compound annually. He plans to continue this investment for 20 years. Even though he knows he won't retire for many decades. Jasper is curious to see how much his investment will grow by the end of this period.
Okay, so now we'll go to the problem solution. We'll use the derived equation to solve Jasper's problem. The first half of the equation is to calculate the initial principal growth, which means the future value of the initial capital compounded continuously at an annual rate over time. And the second half of the equation is to calculate the future value of regular deposit, which means the future value of a series of continuous annual deposit over the same period with continuous compounding. So now I will repeat the Jasper problem quickly. Jasper is a first year student and he has 2,000 initial principal, plan to deposit an additional 1,000 at the beginning of each subsequent year into a retirement fund that offers a 4% annual interest rate. And he planned to continue this investment for 20 years, and Jasper was curious about that. How much is investment will grow by the end of this period. So from the Jasper problem, we can know that the initial investment capital is 2,000 and annual interest rate is 4%, the time length is 20 years, and the annual deposit is 1,000. So we will put all the value into the equation, and finally we will get the compound interest of 35,089 ringgit and 61 cents.
Conclusion, differential equation is a useful tool in our daily lives. We demonstrated how separable equation can be used to derive a compound interest formula. After that, we shown how Jasper's principal can grow when put in a retirement fund over a course of 20 years. I hope our video is informative and insightful. Thanks for watching.